formation of thin, simple lens, particularly ray diagramming. There are two types of lens. We have double convex and double concave. We could observe that in a double convex lens, light rays are converging on a certain point, particularly on focus. A double concave lens will diverge the light. The first part that we need to understand is the principal axis. It is a line passing through the center of the sphere and attaching to the mirror in the exact center of the lens. A vertical axis is a line that bisects the symmetrical lens into half. A focal point is when all the light rays that is parallel to the principal axis will meet on this point. And a focal length, that is actually the distance from vertical axis to the focal point. And 2f, like on the previous lesson, we call it as a center of curvature. But when we're talking about lens, we will just call it as 2f. It is the point on the principal axis that is twice as far from the vertical axis as the focal point is. We have three important basic principles when we're talking about light rays. The first principle is any incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and travel to the focal point on the opposite side of the lens. Second principle, any incident ray traveling to a focal point on the way to the lens will refract through the lens and travel to the principal axis. And the third one, an incident ray that passes through the center of the lens will in effect continue in the same direction that it had when it entered the lens. So let's try this first basic principle. Any incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and travel through the focal point on the opposite side of the lens. Let's try rule number 2. Any incident ray traveling through the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis. And rule number 3, any incident ray that passes through the center of the lens will in effect continue in the same direction that it had when it entered the lens. Let's try this converging lens, which is a double convex. We have case 1, case 2, up to case number 5. Let's do case number 1, wherein distance of the object is more than 2f. Applying rule number 1, any line parallel to the principal axis will pass through the other side of the focal point. Rule number 2, any line that passes through the focal point will refract to the other side, passing parallel to the principal axis. Okay, we can skip rule number 3 because we have intersection of these two lines. And there you have your image. It is a smaller image, an inverted image located between f and 2f, and a real type of image. Let's do case number 2. Rule number 1, any line that is parallel to the principal axis, it will pass through the other side of the focal point. Rule number 2, any line that passes through the focal point will refract to the other side, passing parallel to the principal axis. What type of image is being formed? It is a same size image. Still an inverted image, located exactly at twice of the focal point on the other side, or at 2f, and a real type of image. Case number 3. Distance of the object is between 2f and f. Let's do again the same procedure for rule number 1. Rule number 2. And there we have the intersection of two lines. What type of image is being formed? It is a bigger type of image. Inverted after 2f, and the real type of image. This time, let's do case number 4. Distance of the object is at f. Let's do rule number 1. Any line parallel to the principal axis will pass the other side of the focal point. Basically, we have to apply now rule number 3. And therefore, any line that passes at the center of the lens will continue in the same direction. Will there be an intersection of two lines? Basically, the lines that is being formed are parallel. As a result, no image formed. Case number 5. Distance of the object is before f from vertical axis. First, applying rule number 1, any line that is parallel to the principal axis will pass to the other side of the focal point. But this time, let's try to extend the line. Next, applying rule number 2. Any line that passes through the focal point will refract to the other side, passing parallel to the principal axis. Next, let's try to extend the image. Extend the line, and then therefore, there's an image which is basically a bigger image, upright image, located before F, and that is between F and the vertical axis, and a virtual type of image. Let's try to explore more on diverging lens, which is basically a double concave. Case 1. Distance is more than 2f. Let's try to see. Rule number 1. Any line parallel to the principal axis will pass through the other side of the focal point. But this time, we have to extend the line, which is it will pass on the focal point on the same side of the object. Next, rule number 2. Any line that passes through the focal point will refract on the other side. If this will be the case, it will refract passing parallel to the principal axis, but this time we have to extend the line again. And upon extension, we could see the intersection of the two extended lines. Therefore, what type of image is being produced? It is smaller, an upright image. It is before F, that's between the focus and the vertical axis, and a virtual type of image. Basically, let's just try to move it onto F. And applying the same procedure, upon extension, we could see that that line, the extended line, must pass the focal point. Same procedure, line that passes through the focal point will refract, passing parallel to the principal axis, but this time we have to extend it again on the other side. Let's try to observe the intersection of these two extensions, and look, the image is still same as with the case number 1. So it is smaller, upright, before F, and a virtual type of image. Now let's try again to move the image from case number 1, which is between F and 2F. Let's do the same procedure. Rule number 1, it will pass on the focal point, but take note that the extension must pass on the focal point. Next, rule number 2, another line passing to the focal point on the other side will refract passing parallel to the principal axis, and upon extension, we could observe that the image that is being formed has the same characteristics on the previous one. So it is still located before F, between F and the vertical axis, a smaller type of image, an upright image, and a virtual image. So we can see now a pattern between this concave lens. Wherever their location is, it has the same characteristics. Smaller, upright, before F, between F and VA, and virtual. So, you are now ready to do your worksheet, and we will try to explore this in the laboratory for the actual image that is being formed. Thank you for listening.